What's going on, everyone? My name is Matthew Webb. Welcome to another AVS YouTube video. Today, we're going to go over how many IPs I need for HCX. This was, a very common thing that I worked with customers on during pre-rec planning. If you don't know, especially if you're a bigger organization, this is definitely more relevant for larger environments, this IP planning for HCX. If you're part of a large organization, you may not directly own the networks. You may have to reserve the IP addresses out of those networks with your network team. And so a common thing we discuss as a part of prereqs of installing HCX is understanding what IPs we need and which networks. And so that's where this content comes from. So are you prepared, right? How do we get prepared? Well, first, before we get started, let's focus on some clarification things because it can get a little confusing for people that haven't touched HCX before. A common misnomer is that you'd be deploying the service mesh appliances I'm going to talk to. When I talk about service mesh, that's sort of the interconnect of appliances to facilitate migrations that reside in your on-prem and AVS environment. Okay, so HCX deploys those service mesh appliances. You do not deploy those service mesh appliances. You do deploy the connector. So that's typical OVA deployment that you'll be very familiar with. When it comes to the, so that's number one. The second piece is the HCX deployment in AVS is automated. So when we talk about planning for IPs, those are already done through just giving AVS a /22. It deploys through infrastructure as code. When you go click that add-on button and click deploy HCX, it makes the network profiles and the compute profiles. And that's where this IP planning comes into, is like, what IPs do I need to plug into the network profile to make sure that my service mesh and HCX interconnect actually works to do the migration. So that's the whole idea behind that. So we need to understand the topology view of how HCX works. So let's go over this for a second, and then we'll talk about how IPs play into all these different appliances that get into this mix. So first and foremost, your on-prem environment is on the left side, AVS is on the right side, and then you've got your different HCX appliances. So these hosts make up my vSphere hosts on-prem, and then your vSphere hosts in AVS. So everything in purple here are the HCX appliances. So we first have the HCX Cloud. That's the actual UI you log into when you've deployed HCX in AVS, and that's where you log in and get your HCX Connector OVA. So you're going to deploy that OVA on-prem, and you'll need an IP address just like you would do any other OVA deployment. So the HCX connector goes on-prem. And then once you log in and do some initial configuration, you set up a relationship with vCenter with the HCX connector. And then you start creating your network profiles and compute profiles. And when you create those and you create a service mesh, it'll deploy IX appliances and network extension appliances. How many of these actually get deployed is going to be dependent on multiple factors. And that's actually what we're going to get into in the next section. So most important part, you'll have the sort of the brain, right? The HCX connector appliance, and then you're going to have the data movers and network extension appliances. So the IX or interconnect appliance and the network extension appliance. You may actually have a little bit more than this, but this is going to stick to like the most common deployments. You may have like an OSAM appliance for if you're bringing in non-vSphere workloads, but I just want to mention that. I'm not really going to cover that in this section. All right, so I know what's at play. I know the topology. I understand the appliances at play and sort of the top, the communication, or I'm sorry, the topology and the architecture. So what do I need to know when it comes to planning for HCX and the appliances? Well, one, the HCX connector has a one-to-one relationship with vCenter. So if you have multiple vCenters in your data center, you're likely going to have multiple HCX connector appliances. The exception to that is if you're not moving VMs from those other vCenters. Maybe you get some vCenters that are old and going to be deprecated anyway on older hardware or whatever the case may be. But if you have VMs in the inventory of a vCenter you plan to move, you're going to install an HCX connector. There's only one IP address per vCenter, per HCX connector. So that's pretty simple, not complicated there. And so number of connectors equals number of vCenters you're migrating from. Where it gets interesting is the IX and network extension appliances. These may have multiple interfaces depending on your network architecture. So if I'm going to go back here, the thing to keep in mind is the IX and NE are going to have to communicate with different networks depending on the services you choose. Let's go, you're going to use vMotion and you're going to use network extension. Okay, so the IX appliance will need to communicate to the vMotion network, and it will need to be able to communicate to the management network to be able to perform a vMotion, an HCX vMotion. So the management network, you can go look at all the ports it's talking to, but mostly it's gathering information on the virtual machine, inventory details, and then using vMotion to actually send the data to the destination environment. And then the network extension needs to communicate to the ESXi host to understand the virtual distributed switch and hang a leg into that network to intercept traffic to extend layer 2. Now, you could have even more interfaces need, and that's what each of these little lines is representing, is like a network interface of how these are connecting to the infrastructure to perform these migrations. So you could have just two interfaces, management and vMotion for the IX. You could actually have a third that represents the uplink interface if the management network cannot communicate to the destination site. They have to have, essentially the I here for the IX, I stands for initiator, and the R stands for the receiver. So those have to communicate, and then each local appliance has to communicate with your local vSphere infrastructure, right? So that's how that communication happens, and that's what drives the tool to be able to work. So on the IX appliance, you're going to have at least one IX appliance per service mesh. So why might I have other service meshes? Maybe you have different vCenters. The service mesh is housed by an HCX connector. So if you got two HCX connectors, you got two separate service meshes. So that's one reason. Another reason you want to separate out migration workload, could be one reason, or there is actually specifically vMotion networking differences across your clusters could be another reason. So you can have multiple service meshes. Keep in mind that there's only one IX appliance per service mesh. Understand all the different networks that you could have, just like we were seeing in the previous slide. If you have multiple networks for each of these services, replication, bulk migration uses replication. So if you're a big SRM shop and you have replication on a separate interface, you need to make sure that the IX appliance can communicate to the replication interface to be able to perform bulk migrations. If you're just doing vMotion, it's not a big deal. You just need to make sure that the IX can communicate to the vMotion network. I'll tell you that in my experience in most configurations we did, we just had a management and vMotion interface. So the IX just needed to communicate to those two because the management network typically had firewall rules open to get to the AVS receiver appliances. And that's what drove those requirements. So usually with the IX, you're planning for 2 IP addresses per IX appliance, one sitting in the management network, one sitting in the vMotion network. The network extension appliances, usually just like the IX appliance will have a management network, the network extension appliance will have a management network. And we don't always have uplink interfaces. So again, that's only going to be necessary if we need to communicate to the destination environment because the management network can't do it. So usually the network extension appliance it just has one IP address, and that's on the management network. What drives the number of IPs that you'll need to put in the IP pool is the number of network extension appliances. And there are a couple of reasons why you have more than one, right? One would be you have a lot of concurrent extensions you want to do. So maybe you have 12 networks that you want to extend. Each network extension appliance can do a maximum of 8 concurrent extensions. So you would need to actually have 2 to be able to do a total of 12. So that would be one reason. The other reason would be performance. Maybe a couple of the networks you're extending, maybe you're only doing 4, but 2 are really, really busy. You may need to deploy an extra one to be able to balance out the performance of that across more network extension appliances. There's maximums on ConfigMax, broadcom.configmax.com. If you're not familiar with it, go to it. It'll tell you what those throughput numbers are. But that can vary in my experience. Just keep an eye on those network extension appliances within the vCenter UI to see how the CPU is doing. And if CPU is constantly high, you may need to go ahead and deploy another network extension appliance. Another reason would be network extension HA. So let's say we take that 14 again. I need to have two, but I need to times that by two because each network extension appliance will have an HA pair to be able to take it over. And this gives you more availability faster than like an HA can occur on vSphere. The one thing I'm not absolutely certain on, so if someone wants to correct me, I'd be open to it in the comments, or if you want to reach out to me on LinkedIn. AVS has a maximum of 10 network extension instances per AVS instance. I believe that's still true. If that's wrong, certainly let me know. I'd like to update it in the comments or summary section below. Okay, so I know this feels like an AZ 104 case study type of question, but I want to put this into action so you can kind of see and feel, how different real world requirements drive a variety of IPs needed for HCX. So let's do this. I have 3 sites, all with their own vCenter. I plan to move some workloads from 2 sites into AVS. My first site is large with 3 clusters. I have prod, dev, and UAT. We did keep all 3 clusters on their own separate vMotion network. We want to use network extension on the first site and plan to extend 14 networks concurrently from the prod cluster, but less than 4 on the other clusters. We will want network extension high availability. The first site has an express route 10 gig connection. The second site is small with 1 cluster. We plan to re-IP workloads as we move. Okay, so let's take everything we learned into action. How many IPs and appliances will we actually have? So we mentioned that we have 3 sites, but we're only moving VMs from 2. So we know we only need 2 HCX connectors. There's no point in deploying a third if we're not going to migrate from that vCenter. How many service meshes will we have? Well, in the 2 vCenters we were talking about, one has 3 clusters, but those 3 clusters are all on their own vMotion network. And so since they can't talk to each other, we'll need to have a service mesh per cluster so that we can actually vMotion those virtual machines into AVS. So that's going to drive a total of 4 different service meshes. So we got the 3 on site 1, and then we got 1 more on site 2. And then there's no mention of the management. I didn't really put that in management talk into the AVS. I assume we can go ahead and reach the AVS receiver appliances from the management network and just open up a firewall. So we'll just stick with we're going to go across the management network for that. So we know each IX appliance will have to have a management IP and it will have to have a vMotion IP. How many network extension appliances? So we're taking those maximums, they're coming up to play because we know we have 14 networks concurrently, but the other ones don't necessarily need more than 1. So we know in the first prod cluster, we need at least 2. And then we've got a cluster of dev and UAT, so that's 2 more. So we're going to have a total of 4. But then we know we're using network HA to maintain high availability. So now that moves it to 8, right? So we need 8 network extension appliances. Each of those will need its own IP. So we've got 8 IPs on the management network for network extension. Then we've got 4 IPs on the management network for the IX appliance, and then 4 for the vMotion as well. So that kind of covers the topic. Thanks for sticking through on the video. If you have an idea, this is a community-oriented channel. I'd love to collaborate with you or anyone that has AVS experience on a video. If you think you've ran into something unique or nuance, you have tribal knowledge you want to share, reach out to me. I'd love to collaborate with you on a video. I'm also working on a tool to kind of like take the HCX IP calculations and put it into action. So look out for that. You can reach out to me on LinkedIn and I'll post it there. Appreciate your time today. I'll see you on the next video.